So, hello everyone. I'll be making a presentation and I'll be showing you the presentation about the science fair project of hydraulic lift. The introduction, the title of the project is Hydraulic Lift Using Fluid Pressure to Raise Heavy Objects. And the driving question is, how does the size of the output syringe affect the lifting power of a hydraulic system? What is STEM SOS? STEM SOS stands for Science, Technology, Engineering, and Math Student-Oriented Solutions. It is a program that helps students explore real-world problems through hands-on projects. And STEM SOS encourages creativity, teamwork, and scientific thinking. It gives students a chance to ask questions, test ideas, and build solutions, just like I did with my hydraulic lift experiment. The background, I chose this project because I've always been curious how machine like car jacks and construction lift can raise super heavy things with just a little push. It seemed like magic, but so I wanted to learn how it works and try building one myself. What I learned before starting, I found out that hydraulic lift uses liquid to move force. The main idea comes from Pascal's law, which says that when you push on a fluid in a closed space, the pressure spreads out evenly. That means a small push in one spot can create a big lift somewhere else. I also learned hydraulic systems use things like syringes and tubes filled with water or oil. The size of the pistons, the parts that move, matters. A bigger piston can lift more weight. This is how real machines like forklifts and car lifts work. And the hypothesis I created was, after learning all this, I think that if I use a bigger output syringe in my lift, it will raise heavier objects even if I use the same amount of force on the input syringe. These are the resources I used. I used Science Buddies, I used Khan Academy Science, and I used Steam Powered Family. The abstract, the purpose of the project, I wanted to understand how machine like car jacks and forklifts can lift heavy stuff using liquid pressure. The hypothesis, I thought that if I used a bigger output syringe, it would lift heavier objects even with the same input force. The brief procedure summary: I built a hydraulic lift using syringes and tubing filled with water. Then I tested how much weight it could lift by changing the size of the output syringe. The key result: the lift worked better with a larger output syringe. It could raise heavier objects with less effort. The conclusion: I learned the Pascal's law really works. That the Pascal's law really works because pressure in a fluid spreads out evenly, and using a bigger piston helps lift more weight. The materials I used and the procedure and safety. Materials was 2 plastic syringes, different sizes, clear plastic tubing, water, cardboard, or wooden base, tape or glue, small weights like washers or coins, a ruler, and the scissors. The procedure was to fill both syringes with water and connect them using the plastic tubing. Tape the syringes to a sturdy base so they don't move. Push the plunger of the smaller syringe to apply pressure. Watch how the larger syringe lifts the weight. Try different sizes of syringes and record how much weight each can lift. Safety, I wore safety goggles while working with the water and tools. I used scissors carefully and had an adult nearby while building. I made sure the syringes were sealed tight to avoid leaks or spills. This is the hydraulic lift test results. The x-axis is the output syringe size, mLs. The y-axis is weight lifted, grams. And the trend as syringe size increases, the lift strength also increases, proving my hypothesis. This is the data analysis. The output syringe, small, 10 ml. Weight lifted was 50, and notes: needed strong push. The medium, the weight lifted was 150 and easier to lift. The notes were easier to lift. The large was 30, and the weight lifted was 30 grams, and the notes were lifted with light push. My analysis was the data shows that larger output syringes lifted more weights with less effort. As the size increased, the lift became easier. This supports Pascal's law. Pressure spreads evenly though the fluid, and a bigger piston creates more force. The independent variable was the size of the output syringe. The dependent variable was weight lifted, and the control variables were type of fluid, tubing length, and input syringe size. So my conclusion, my hypothesis was correct. A larger output syringe lifted heavier objects using the same input force. I learned how hydraulic systems use fluid pressure to multiply force and make lifting easier. So ELA component. For my hydraulic lift project, I used reading, writing, and communication skills to understand how fluid pressure works. I read articles and watched videos about Pascal's law and hydraulic systems. Then I wrote my research in my own words and used it to build my hypothesis. I also organized my results into charts and explained them clearly in my presentation. This helped me practice writing scientifically and speaking confidently about my experiment. Social studies connection, real world impact. Hydraulic lifts are used in everyday life to help people work safely and efficiently. They're found in car repair shops, construction sites, elevators, and even airplanes. These machines make it easier to lift heavy objects with which helps workers avoid injuries and get jobs done faster or easier. Society, environment, and communication. Hydraulic systems reduce the need for manual labor and make dangerous tasks safer. They also help in rescue operation like lifting debris after a natural disaster. Using water-based systems can be more eco-friendly than machines powered by gas or electricity. Science and technology in our lives. Hydraulics show how science and engineering solve real problems. They use pressure and fluid mechanics to create powerful tools that help people every day. Historical context. Hydraulic technology is based on Pascal's law, discovered by Blaise Pascal in the 1600s. This work led to inventions that changed industries like transportation, manufacturing, and medicine. So for the conclusion, through this project, I learned how hydraulic systems use fluid pressure to lift heavy objects. I saw how Pascal's law work in real life. A small push on one syringe can create a big lift on another. My experiment shows that bigger output syringe can lift more weight with less effort. This helped me understand how science and engineering solve everyday problems. Thank you for your time.